Hello dear students, and welcome to Unit 5, Principles of Chemical Engineering, Mass Transfer. In this unit, we will be exploring one of the key concepts that underpins many chemical engineering processes, mass transfer. Mass transfer refers to the movement of substances from one location to another, and it is a fundamental concept in processes such as separation, mixing, and chemical reactions. Okay, guys, let's get started. Mass transfer operations are directed towards separating a substance into its component parts. For mixtures, such separations may be entirely mechanical, for example, the filtrations of a solid from a suspension in a liquid, or the separation of particles of a solid mixture according to their density. These aspects are covered in mechanical unit operations. On the other hand, if the operations involve changes in composition of solution, they are known as mass transfer operations. The importance of mass transfer operations in chemical engineering is profound. There is scarcely any chemical process which doesn't require either a preliminary purification of raw materials or a final separation of products from byproducts, and for this mass transfer operations are commonly used. Examples of mass transfer operations are absorption, adsorption, distillation, extraction, stripping, distillation, and extraction. Okay, guys, so absorption and adsorption and understanding the difference. In the context of mass transfer, adsorption and absorption are two important processes used for separating or removing substances from a mixture. While both involve the interaction of a substance with a surface, they differ in terms of mechanisms, application, and the way substances are retained. So, let's explore each of them in detail. What about adsorption? Adsorption refers to the process in which one substance by another substance diffuses into the bulk of the adsorbent material. In absorption, the absorbed substance becomes formally distributed throughout the absorbing material. What about key features? A phase change process. Like an example, a common example is carbon dioxide. Water dissolves into water, forms carbonic acid. Another example is gas absorption, where gases like ammonia and sulfur dioxide are absorbed by a liquid solvent. And as for adsorption, on the other hand, is a process in which molecules substance accumulate or adhere to the surface of a solid and or a liquid. So key features of adsorption, surface interaction, no phase change. As example, common example of adsorption is gases, adsorption of gases like oxygen or nitrogen on the surface of activated carbon. Carbon is commonly used to adsorb from gases or liquids. And another example is adsorption of water vapor on silica gel, which is commonly used as a desiccant. Understanding diffusion. Diffusion is a process by which molecules, ions, or other small particles move from regions of higher concentration to regions of lower concentration due to random molecular motion. This process continues until equilibrium reached, meaning the concentration is uniform throughout the system. In chemical engineering, diffusion plays a critical role in many processes such as mixing, chemical reactions, and separation operations. As for Fick's first law, diffusion is a process by which molecules, ions, and other small particles spontaneously mix, moving from regions of relatively high concentration into regions of lower concentration. And this tells that rate of change of concentration at a specific time and the position is proportional to the second derivative of concentration profile. So Fick's first law is a fundamental principle used to quantify diffusion, and it shows that rate of diffusion is proportional to the concentration gradient. And this law provides a mathematical framework to calculate and predict the rate of diffusion, which is crucial for understanding various natural and industrial processes, including gas absorption, filtration, and mixing. In contrast, the mass transfer model is said to have lumped parameters like the average concentration in the metal. The diffusion model is more fundamental and is appropriate when concentrations are measured or needed versus both position and time. The mass transfer model is simpler and more approximate and is especially useful when only average concentrations are involved. Okay, let's sum up our lesson for today. So, mass transfer is a fundamental process in the study of chemical engineering, affecting how substances move through different media. Understanding mechanisms such as diffusion, applying tools like Fick's first law, allows engineers to optimize systems for separation, purification, and reaction processes. And the ability to control mass transfer is essential in industries such as pharmaceuticals, food processing, and environmental engineering, where efficiency and precision are key. So, dear students, that is the end of our video session for today, and thank you for joining in the discussion today. And I hope this video session of mass transfer has been insightful and useful for your understanding of this critical aspect of chemical engineering. So that is the end of our video session. Thank you for your attention. Goodbye.